Hi everyone, welcome back to my YouTube channel. This is Maunika, currently pursuing computer science and engineering from Sri Venkateshwara College, course title Mathematics for Computer Science. Today I will discuss about higher transition probabilities and its applications. These are the table of contents we will be discussing in this session. Introduction, definition of higher transition probability, understanding transition matrices, calculating higher transition probability, example problem and solution, application in mathematics, real world application, conclusion. Introduction. Higher transition probability is a concept in probability theory that focuses on likelihood of transitioning from one state to another over multiple steps within a system. This is especially useful in understanding systems where each state's future depends only on current state, such as in Markov's chain. By analyzing these probabilities, mathematicians and scientists can predict long-term behavior in various fields including economics, biology, and machine learning. For example, in weather model, higher transition probability can help forecast the chance of specific weather condition after several days given today's state. This technique is built on the use of transition matrices, which represent probabilities of moving between states and can be raised to power to predict outcome over multiple transitions. This introduction to higher transition probability sets the foundation for exploring its mathematical properties and practical applications in analyzing dynamic state-based systems. What is higher transition probability? Definition. Higher transition probability refers to finding the probability of moving to a specific state after multiple transitions. This is useful when studying the long-term behavior of a system as it shows how likely certain outcomes become over time. Example. Suppose you travel between cities with each transition being a city hop. Higher transition probability lets you to calculate the chance of reaching a particular city after multiple stops. Importance. This concept is useful for predicting where a system might be over multiple transitions, especially when the individual transitions have their own probabilities. Understanding transition matrices. Transition matrix. This is a mathematical table that lists the probability of moving from one state to another. Each row and column represents a state. Example, a simple weather model could have a matrix with rows and columns for sunny and rainy, where each entry is the probability of moving from one weather condition to another. If we have matrix T is equals to 0.8, 0.2, 0.6, 0.4. 0.8 is the probability of staying sunny if it is sunny today. 0.2 is the probability of going from sunny to rainy. 0.4 is the probability of going from rainy to sunny. 0.6 is the probability of staying rainy if it is rainy today. Higher transition probability in matrices. To calculate the probability of moving to a state over multiple steps, you raise the transition matrix T to the power of number of steps. For example, to find the probability after 2 steps, calculate T square. Calculating higher transition probabilities. Step-by-step process. Start with an initial state vector. This vector represents the starting probability of each state. For example, if we are sure that it is sunny today, the initial state vector might be 1, 0, 1, 0, 1, 0. 100% sunny, 0% rainy. Apply transition matrix multiplication. Multiply this vector by transition matrix raised to the power of the number of steps you want. Example, t raised to n for n steps. Interpret the result. The resulting vector shows the probability distribution for each state after n transition. Example, using the weather model, if we want to know the probability of it being rainy after 2 days, calculate t square and multiply the initial state vector. Example problem and solution. First we have to create T is equals to matrix 0.8, 0.2, 0.4, 0.6. Initial state vector. Since it is sunny today, we start with an initial state vector representing the probabilities of sunny and rainy today. Initial state vector is equals to matrix 1, 0. Calculate T cube. To find the probabilities after 3 days, we need to raise the transition matrix T to the power of 3. This gives us probability after 3 transitions. T cube is equals to T into T into T. We have to find T cube. T cube is equals to matrix 0.712, 0.288, 0.576, 0.424. Multiply T cube by initial state vector. Now we multiply T cube by initial state vector to find the probability distribution after 3 days. This T cube into initial state vector matrix 1, 0. Interpret the result. The resulting vector gives the probability for each state after 3 days. The resultant matrix is 0.712 to 0.576. Application in mathematics. Markov chains. These are the models where future state depends only on the current state. Transition probabilities are key here. Example, a Markov chain can model a simple weather system. If it is sunny, there is a chance it says sunny or turns rainy. We can predict future weather condition based on current probabilities. Stochastic processes. These are processes that evolve over time with the randomness involved, often modeled using higher transition probabilities. Graph theory. In networks, higher transition probabilities can analyze connectivity, such as finding the chances of moving from one node to another through various paths over several steps. Real-world applications. Economics and finance. Higher transition probability models help forecast stock prices by predicting future states of the market. Biology and genetics. Transition probabilities can model genetic evaluation or animal migration patterns by predicting state changes. Machine learning. Algorithms like hidden Markov models use transition probabilities to predict sequences useful in speech recognition, handwriting recognition, and language processing. Physics and chemistry. In physics, processes like diffusion or chemical reaction, higher transition probability model particle behavior and reaction outcomes over time. Finally, I conclude that higher transition probabilities provide a powerful way to predict the likelihood of reaching different states in a system over multiple steps, which is especially valuable for understanding long-term behavior. By using transition matrices and raising them to a power representing the multiple transitions, we can determine how a system evolves over time. In this example, by calculating the probability of weather states over 3 days, we can see how likely is it to be experience different weather patterns based on today's condition. This method has broad application across various fields, from predicting weather and modeling economic trends to understanding biological processes and powering algorithms in machine learning. Ultimately, higher transition probabilities helps to simplify and solve complex prediction problems by focusing only on current state and transition probabilities, making it a fundamental tool in probability theory and applied mathematics. Thank you. Like, share and subscribe my video.